Hello, good morning. Good morning, my students, and good morning for those who are watching. Good afternoon, good evening, depending on the time you are watching this particular video. I am Teacher Patrick. So today I want to take you on physics practical, and this is a yellow paper question that came out, and I want to tackle question 2 of it. Okay, so physics practical is simple. So far, you know how to plot your graph. So far, you know your y-axis and you know your s-axis, or you know the particular axis that is involved in that particular question. But before that, let's get a glimpse of how the likely questions you're going to see under this particular type of question. In case you see, so this is a yellow paper. So this is the format of the yellow paper. You say question 2. It says two spiral springs of nearly the same spring constants. 2. Fixed stand, rotor stand. 3. Stopwatch. 4. Slotted masses. So these are the things that you need. So you need to set up these things. Okay? So anybody can do it. So far you have the knowledge of basic knowledge of physics. Anybody can, men looking at this, the person can know the likely questions that are going to what? To come out. Okay? So now, for us not to waste time, I'm going to bring out those likely questions. I'll drop it on the board, and you know that these are the likely questions you are going to prepare towards what? The exam. In case you see such thing. And take note, this is physics practical. Okay? So now, the likely questions. If you notice very well, the apparatus here are two spiral springs, rotor stand, a stopwatch, and slotted what? Masses. So meaning, this is how the questions is going to be like. So first one, apparatus. Spiral springs, rotor stand, stopwatch, slotted masses. So take note, I said likely question. So the question we're going to see from here, the question we're going to see from here, the experiment is going to come like this. So we're going to bring out up to like what? We're going to bring out up to like 3 or 4 experiments, okay, for this particular question. So the first experiment is going to be like this. It's going to be determine the effective spring constant and acceleration due to gravity, which is what? G, during oscillations. Okay, so we're going to get the effective spring constant. And if you look at this question, you notice that they say two spiral spring what? Constant. Two spiral spring of nearly the same constant. Nearly the same. So we're going to get two constants there. So if you notice very well, determine the effective spring constant and acceleration due to gravity during oscillations. Okay? So now, that is the question that what we're going to what? Get under it. Now, take notes. So I said this is what? This is what? The first what? Experiment. Okay, so under this first experiment, these are the things that they're going to say you should do. They'll say you should what? They say you should get the value of t. And what is this t? We call it what? Period. Get the value of what? T. Get the value of t. And again, B, How does the effective spring constant of two spring constants of two identical spring. In series compared to a single spring. So let's get the answers ready for this particular set of questions. Answers. So let's get the answers ready. Okay, so now let's go back again. Get the value of t period. How does the effective spring constants of two identical springs in series compare to a single spring? Now, to get the value of what? The period. So these are the things that you need to do. These are the things that you need to do. So now, to get it, the value of what? Period. Now, the value of period A, which we know is given as t, is equal to 2 pi square root of m over k. This is the formula you use to get the what? The value of what? The period. Now, take note. This is pi, is a constant. Pi is always given as 3.142. While m here is the masses. And if you look at that question, masses is involved. The slotted what? Masses are also there. Okay? So they will give you the value. So once they give you the value, you can put the value inside this formula and you start getting the period for each of the masses. For each of the masses. So they can give you up to like 5 masses. So you'll be getting the periods for each of the masses. Okay? Now, these are the masses. K here is what we call the spring constant. That is that spring constant that we said earlier. Determine the effective spring constant. Okay? So now, this pi is 3.142, which is what? A constant. Spring constant also, and what? The masses. So, each of the masses will be given to you. So, they'll tell you the number of masses you're going to use. Basically, the highest is 5. They can give 10, 20, 30, 40, 50, and you use it. So once you input the values, the masses here, and your spring constant, which will be given to you also, you put it here, you get the masses for each, you get the periods for each of the masses. Okay? Now, the second question, which is B. How does the effective spring constants of 2 How does the effective spring constant of two spring of two identical springs in series compared to a single what? Spring. Compared to a single spring. Okay, so let's start. Let's start. Now, to get it, these are the things that you're going to use. So that's, you're solving for question B now. Now, this spring constant we are going to find, there's something we need to know about this spring constant. If you remember Hooke's law. So we'll look for B. Recall Hooke's law. Now, Hooke's law states that F is equal to KE, where this our F is force, this our K is the spring constant. That's what you're saying here. Why this our E is extension. Okay? Now, this Hooke's law, recall, it says, how does the effective spring constant, and take note, we said that we are using two spring constants to solve this question 2, because it says 2. If you can recall, it says 2 with slotted masses and stopwatch. So because it says 2 and they say they are in what? Series. They are in what? Series. So meaning for us to solve it, if they are in series, since we're going to use two constants and they are in series, so this is what you're going to do. Take note, identical spring in series. Since they are in series, so it's going to be 1 over K is equal to 1 over K1 plus 1 over K2. And this is what you use to solve spring constant that are in series. Take note. So this is what you use to solve spring constant that are in series. So this is what you're going to use to solve spring constant that are in series. Take note. Remember this. Remember it's 2. That's why we have K1, K2. Take note because it's 2. That's why we're having K1, K2. That is why. Okay? Now, if you recall, any answer that you have here, that's what you're going to use here as your K. And take note, it says effective. It says effective what? Effective what? Spring constant. So since it says effective, I can put E here to make it to be effective. So that was the reason. I didn't put it initially, but I have to place it here. Now, can we get this our K? KE. Let's get it. So let's go. 1 over KE. Now, take the LCM. Okay, so let's go. So now, if you notice very well, it says, so this is, since they are in series, so this is what you use. But the same question says identical spring. When it's identical, I mean they are the same. So meaning, if they are the same, meaning they are going to have the same what? Spring constant. Are you guys getting me? If they are the same, I mean they are going to have the same spring constant. Okay? So meaning, I'm going to say, assuming they are the same / identical. Therefore, my K1 will be equal to what? K2. my K1 will be equal to K2. So any place I see K1, I put K2. Any place I see K2, I put what? K1. Why? Because it says they are the same and they are what? Identical. Okay, so that is it. So watch. We're still on it. So we are still on it. So let's go. Let's finish it. So let's go. K1 is equal to what? K2. So let's go. So it's going to be 1 over Ke is equal to, so since they are identical, any place you see K1 you put K2. Any place you see K2 you put K1. Vice versa. So let's go. 1 over K1 plus 1. So I'm using K1 now. K2 becomes the same K1. Vice versa. So watch. 1 over Ke is equal to K1, K1. LCM of K1 and K1 will give us what? K1. K1 cancel K1 is 1 times this one here, 1. K1 cancel K1 is 1 times this one here is 1. So just watch. 1 over Ke is equal to K1, 1 plus 1, 2. We can now cross multiply. So when you cross multiply, you have 2Ke is equal to K1. Ke is equal to K1 divided by 2. And this is the spring constant when they are of the same, what? Spring. Identical. But if they are not the same, this is your answer. Series. But if they are of the same, but if you look at the question, they say compare to a single, compare. If you look at the question, let's go back and say, how does the effective spring constant of two identical springs in series compare to a single spring? So this first one we solved was for what? Double spring. Why? This is for what? Single spring. Okay, take notes. Single, so same, identical, slash same. Okay, so this is the likely questions you are going to see under this. Take notes. Take note. This is a series connection of it when it is in series. Okay. We also have the parallel. So, but we'll come to that. For now, this is the series connection of it. So with this one now, so let's write a short note under it. The comparison. Let's cross. If you not notice very well, this is half, right? This is half. So the final comparison here is this. So the final comparison is at the end. And what is our conclusion? At the end, the effective spring constant of two identical springs in series is half of a single spring. That is Ke is equal to K1 over 2. And that is it. So this is how you solve that question. Take note, I say these are likely questions that you're going to what? See. These are likely questions that you're going to what? See. Okay? So these are likely questions that you're going to see. Now, under the same experiment, there are things you need to know, precautions that you need to know under this experiment. So precautions is the next one I want to do. Precautions. So I'm going to clean. So precautions is the next thing we're going to do. So you need to know the precautions. Precautions you are going to take. Because you can't be doing an experiment, you don't take precautions. Yes, those precautions are like the guidelines, the rules, okay, the laws, the principles involved in what? In this particular experiment you are going to do. So I'm going to list out all the precautions. Okay, I'm going to list them out. And these precautions are very, very what? You apply them. They always give 2. They don't give more than 2. They always give 2. Yes, 2 or 3, but I know it's only 2 they give. So try and memorize it very, very well. What I say? Try and memorize it. If you can memorize up to like 3, if you enter the exam hall, you write. Okay? So let's move on. Precautions. One of them, ensure the weight do not touch the table or stand. Meaning, if you are performing the experiment, remember it's a stand. It's something that is standing. So if you are performing the experiment, you ensure that the weight do not touch the table, because it's going to be what? Dangling. Vertical oscillation. It's going to be, because it's a spring now, spiral spring. So it's going to dangle. So don't allow the weight to touch the rector stand or the table. 2. Avoid parallax error when reading the scale / rule or meter rule. Parallax error, avoid it. Now you ask me, what is parallax error? If you want to view, don't view by this side. Don't view by this side. Your eye should go directly, as if you are looking at your phone. If you are looking at your phone, you don't view like this, or you view like this. Your eye should be heading towards where you are taking your readings. Okay? So that you don't make mistake of, maybe mistake of 0.02 minus plus 0.02. So everything should be directly to the instrument that you are using. So for now, we're using meter rule. Avoid parallax error when reading the scale / rule / meter rule. So let's go to the third one. Ensure the spring are not overstretched. If the spring is overstretched, it's not making sense. You not really get the proper reading. So avoid it totally. So it should be a new string that I've not used at all. So that's why sometimes this practical, once they give this yellow paper, people rush down to go and get new things. They don't use the one that is already in the lab or that I've used over time. They get new things and they start using it. Okay? Now, let's move to the fourth one. Okay, fourth one. Ensure the support stand is rigid to avoid extra vibrations. 5. Avoid parallel error when reading the stopwatch. You see what I'm telling you? So those are the two. If it's only these two you're able to write, they'll give you your mark. If you write this one, avoid parallel error when reading the scale, avoid parallel error when reading the stopwatch, you get your mark. Sharp mark, you just get it. You get your mark. 2 mark, you just get it. So if it's only these two you are writing, fine. Okay, now let's move again. So let's get some other ones. Okay, I think these are the major precautions that you need to what? To observe. Look at it. Ensure the weights do not touch the table or stand. Avoid parallel error when reading the scale rule or meter rule. Ensure the springs are not overstretched. Ensure the support stand is rigid to avoid extra vibrations. Avoid parallel error when reading the stopwatch. So these are the precautions that you need to what? Observe. Okay, so these are the precautions. Now, once you know these things, calculation is still there. We are going to calculate. So we are coming back to calculation. So when you're going to calculate, the next one is how do you plot the graph? So for now, I'm going to stop here. So what will come next time again? We continue with the aspect of knowing your y and s axis, knowing how to plot your graph, knowing the particular scale you are going to use so you can get your proper slope and your proper graph. Thank you very much for watching. Please subscribe to my channel. Bye bye.